Hi guys, so we are back in chapter 3 again, but this time around is part 3, the final part in the chapter air pollution. Okay, so for this part, we will continue on the types of equipment or devices that is used in order to treat the air pollution. So that's why we call it engineered system for air pollution control. So if you refer to your textbook, this will be chapter 9 in your textbook. Okay, so if you look here, these are the equipment that you will see in this chapter, which is incinerators, scrubber, adsorber, settling chamber, cyclone, wet scrubber, bag filter, and ESP. This is ESP. Okay, so all this equipment depends on the size of the particles or the pollutants. Okay, in this case, the pollutant is the particles, right? Okay, so you need to know the size of your pollutant in order for you to choose which treatment that you are going to use to treat your air pollution, right? So the particulate control equipment, these are the factors that I think you can refer to the textbook table 9.2, page 520 on how on the factors that need to be determined in order to choose a proper equipment to treat your air pollution, right? Okay, so these are the 5 major equipment to use in order to treat your air pollution, the contaminants. Okay, this is focused on the particulate or particles. Okay, by the end of this topic, you will see there's another type of pollutant, which is gaseous pollutant. So that one we will see another type of control devices on how to treat the contaminants. So now we focus on this 5 first. Okay, number 1 is gravitational settling chambers, and then centrifugal collectors, wet collectors, ESP, and fabric filters. Okay, so I only will describe briefly in this lecture note, so I hope that you may refer to your textbook for further explanation. Okay, so the first one is gravitational settling chamber. Okay, it uses the force of gravity to remove solid particles. So I think later you will see there's a BT, which is terminal velocity. This one is like similar as the one in wastewater treatment chapter. Okay, I think it's in, if I'm not mistaken, it's chapter 2 or 3. Chapter 3, I think. Chapter 2 or 3. So you will see back again the formula on the terminal velocity. Okay, so the concept of this settling chamber, gravitational settling chamber, so the dirty gas will enter here, and then the large particles, okay, so the large particle will drop onto the dust hoppers. It will be collected here. So the clean gas will exit in this part. Okay, right, so we need to know what is the terminal velocity in order to solve that. Okay, it's either given you the dp, particle diameter, okay, and then you solve for the h, or the length of the bag, the length of the chamber. Okay, so rho p is the density of the particle, g is the gravity, mu is the viscosity of the gases. Okay, right, so this is application of Stokes law in this calculating the dp, or let's say vh or vt in the gravitational settling chamber. Okay, so the next equipment is centrifugal collectors. Okay, the next one is cyclone. Okay, so it uses centrifugal force instead of gravity to separate particles from the gas stream. If you look into the figure, this is the dirty gas. Okay, so the dirty gas will enter here and will separate the pollutants, okay, the particles from the air stream or the gas stream. using the centrifugal forces. So the particles will fall down to the bottom part of the cyclones, okay, and the clean air will exit at the top of the cyclone, right? So, right. So this is the formula that you can use that is being used in this centrifugal collectors. Okay, so you can determine the D50 diameter of the particle with 50% efficiency. So mu is the gas viscosity, B is the width of cyclone inlet. Okay, NE is number of effective turns, okay, within the cyclone, because it's like rotating, right? And then VI is actually the inlet gas velocity, rho P is density of the particulate matter, right? So the next equipment used to treat the air pollution, okay, is wet collectors. Okay, so it incorporate the particles into liquid droplets. Okay, it has spray towers. Okay, if you look into this figure, okay, this is the spray towers. You can see there's a small hole there where when the dirty airflow will come through from the bottom part of the collector. Okay, so it is like counter currently. Okay, and then this the droplet of the water, okay, is being sprayed out from this, you know, you see the cylinder part, so that's why you would call it spray towers. Okay, so this droplet will spray across the flow passage, and then and then will grab the particles, and it will fall by the gravity force to the bottom of the chamber, and then the clean air will exit through the top part of the chamber or the tower, right? So this is the other part of wet collectors, the other type, which is wet cyclone scrubbers. Okay, so this one use high pressure spray nozzle. Okay, it's a rotating. If you can see here, the spray tower is rotating. Just now it's only flowing downwards. Okay, but the concept is just the same. Okay, use water. So the next one is Venturi scrubber. More or less it's just still the same. Okay, scrubber use water as well as what in the wet collectors. Okay, so the concept is the same. Use water to remove the pollutants. Okay. Okay, this one is a fabric filter or baghouse filter. Okay, this is it removes dust from gas stream by passing stream through porous fabric. So you can see here, so the filter bags is being assembled. Okay, so you will have actually not only 10 filter bags, it will be a lot. Okay, to filter the pollutant. Okay. And then this is ESP. It use electrical forces, okay, to move the particle out from the flowing gas. So actually, the electrical forces is in here. Okay, there's a negatively charged wire and negative electrode connected to electrical power source. So it will charge the particle. So it will the different charge will goes to the different, let's say the pollutant is now is positive, and it will attach to the negatively charged wire, and then the clean air will exit at the stack here. All right, so this is what the formula used to calculate the efficiency of using the ESP, right? So later you can have a look in the textbook. Okay, so the equipment I've explained just now are focused more on the particles. So now is a control devices on gas pollutant. Okay, let's say you have sulfur dioxide gas, or let's say acidic gas. How are you going to treat that kind of contaminants in the air, right? So there are in this chapter there are 4 process that we use in order to treat the the gases contaminants, right? So the first one is adsorption and then absorption. I hope that you can differentiate between these two, right? And then condensation and combustion. So this is example of adsorption where they use a carbon bed, and then let's say this the steam generator. So the contaminate gas, okay, will come through the carbon bed. Okay, it will be absorbed. Okay, and then it will continue exit. Okay, this is like series, I think, or maybe, yeah, series. Okay, you have to this in the picture, in the diagram is actually is in series. Okay, and then the second one is using absorber, is like scrubber. It's function like scrubber, but scrubber just now is to strip the um particles, right? But in this case around, we want to absorb the contaminants that comes from the gas. Okay, so this is your gas in. It can be either one. Okay, the gas can come from the top part of the absorber, but normally we use it counter current. It's not in a parallel. All right, so the clean gas is on the top of the absorber. So what we call it stripping, the liquid will absorb all the contaminants and leaving the absorber. So this liquid should be treated in wastewater treatment. Okay, the next one is condensation. We use, if in this figure, is like an heat exchanger. Sorry. And then the last one is combustion. Okay, so I think that's all for this chapter. So for example, you may refer to your book in chapter 9. Okay, try to focus on example 9.1. Try to understand that one. 9.2. Okay, 9.1 and 9.2. Right? Okay, see you in the next chapter. Thank you. Bye.